We will see one more example on steel column design with bending. So this time a W840 welded tension member. It is a tension member, very important to note. 16 feet long, it's subjected to a factored axial tension load of 150 kgs. Factored moment about strong and weak axis. Strong means X, weak means Y. So 30 and 20 kp respectively. Assuming this material, that means grade 50. Grade 50 means yield stress 50 ksi. Braced only at the support. It is a bracing. There is a bracing here. Check if the beam column is adequate for combined loads. So check whether this section W840 is good or no. Now how to solve this equation? So it is the column equation is given here. We have to find everything. Just to note you that this MUX or MUX we do not need to amplify. Whatever is given, that is MUX, this is MUY. As it is a tension member, no buckling, so no B on, so forget B on. So and do the other thing. Okay, what are the other things? We will find this is given how much. This is given 150. So this unknown, this unknown, this unknown 30, this unknown 20. This one we have to find it. This one we will have to find it. This one we will have to find it. Okay, so then we'll find one by one. So ppn as it is axial, that is something to note also. As it is axial capacity, you have to use the axial load equation from chapter 4 most probably of your book. Whatever the chapter, that doesn't matter. It is not the comprehension. Again you might make mistake here, that last time when you were doing column for comprehension you used KL ratio, and from KLA you went to ASC manual, but this time no, it is simply this equation which is axial load capacity. So phi Fy AZ, phi Fy yield stress, AZ gross area. So gross, then we found 520, and this capacity is more than 150. So and it is 0.29, that means more than 0.2. So our first equation. Okay, then we will find load capacity, sorry, moment capacity about x-axis and y-axis. How to find about x-axis? We have to see our LB, LP, LR, everything. So from ASC manual for that section, LP is 7 feet, 7.21, LR is 29. Again, and our, what is our unbraced, unsupported length? R is 16 feet. So it is in between. So in between. So our moment capacity will be based on this equation, CB MPX minus PBF LB minus LP. Now CB we assume on, we can find it from ASC manual. This one ASC manual, this one, this time it is 16 feet. This time it is 16 feet. Okay, so we will see here in this example they did not show phi here, but there will be phi. As CB is 1, they did not show it. So now this solution is not so polished, so it's just gross. So hopefully you will understand. Okay, so you will find your capacity, you found it 127. Now you as apply your own knowledge how to find it. It is for unsupported length in between LP and LR. So 127. Now how to find about y-axis? The equation is given PGYFY or 1.5 SYFY, this equation. Now this 1.5 became 1.6 in the new edition. So whatever edition you use, that is okay in class. Now why they used 12 to divide? Because Fy is in KSI, so they divide by 12 to be consistent. Okay, so now again why did use 12? Because PGY is ins, Fy is 50. I do not know why they are using divide by 12, because with 12 we use typically to convert sorry, not keep, feet to inch to feet. Okay, let me check one more time. Gy is in inch. Oh, maybe they converted from inch to feet, because this will be in keep inch divided by 12, it will be keep feet. So this is why they used 12. Okay, we found the capacity, then choose our equation, insert it and find it. So very simple. Now remember, we do not need to amplify because it is a tension. How to find this capacity? Axial tension capacity, tension capacity. This is our moment capacity about x-axis, moment capacity about y-axis. So hopefully you understood. Again, to revise, what is the difference between tension and compression? For compression, we need to amplify this moment, and this equation will come from the compression assumption. Use KL or KL by R, go to table, find the capacity. For tension, we do not need to amplify, and this equation, our tension capacity equation. Okay, thank you.